Howdy, howdy, folks. Once again, it is Donnie, and I'm back at you with another basic Linux lesson. And this time I am doing a lesson per a viewer request. A viewer requested that I create a video about how to partition hard drives in Linux. And it's actually a good thing that the viewer requested that, because I had completely forgotten that I had never created a video about this. So it's about time that I get around to it, right? Anyway, let's go ahead here and take a look first at our two different partitioning schemes that we have. We have the master boot record, more commonly called the MBR scheme. And with this scheme, we can have only up to 4 primary partitions per drive. And if you need more than 4 partitions, you need to replace a primary partition with an extended partition, and then use that extended partition to create logical partitions. So it's kind of complex, right? So in a few moments, we're going to see that we'll have a better way of doing things. But continuing on with the MBR, we can have, with the MBR partitions, a maximum of 16 partitions per drive. It doesn't matter the size of the hard drive, you can only have 16 partitions total. Partitions must be less than 2 terabytes in size. They cannot be used as boot partitions with the new UEFI motherboards. And for partitioning tools, we have Fdisk, CFdisk, Parted, and Gparted, and there are probably a few others as well, but these are the main ones. Next up, we have as soon as I get this right, there we go. Next up, we have the GUID partition table partitioning scheme. GUID stands for Globally Unique Identifier, and this is a lot better than the old MBR. The old MBR, that's old school, right? The GUID partition table scheme is the new thing. It's what all the cool kids are doing now. But anyway, with GPT, we can have up to 128 partitions per drive. Partitions can be up to 9.4 zettabytes in size. Now, I want to see all of y'all trying that on your home computers. Get yourself a 9.4 zettabyte drive and partition that whole thing. But anyway, having said that, that also depends upon which file system you're using to format the partition. Because, like in Windows, you got your FAT partitioning scheme, or rather your FAT file system, and your NTFS. I had trouble thinking of it. Yeah, NTFS file system. But in Linux, you have all kinds of different file systems, and, some of them allow larger partition sizes than others. GPT scheme is required for booting with the new UEFI motherboards. Also, with GPT, you have greater reliability because now you have redundant partition tables. So if one gets corrupted, you still have the other to fall back on. And it also does a cyclical redundancy check of the partition tables. I just noticed there, I got CRC check. So I got a redundancy there, cyclical redundancy check. Yeah, okay. Whatever, right? You know what I mean. And also with the GPT, we require the new Grub2 or the eLilo bootloader. So Grub2, of course, is what you're probably going to be using. The only time you're going to have to worry about Lilo bootloaders is if you ever play with Slackware type Linux distros. And probably, I would say probably not too many of you are going to do that. So anyway, let's go ahead here and see how we can set up 2 practices with this. So what I got here is VirtualBox, and I have a virtual machine here. The one that's highlighted is CentOS 7.3. However, I promise you, it is actually updated to the latest and greatest 7.5 because it just now did that. So it just shows you how long ago it's been since I actually created this virtual machine. But anyway, it is updated, so it's all good. But you can use any type of virtualization manager that you want. If you like VMware Player, that's fine. If you like VirtualBox, that's fine. If you're on like Windows 10, you want to use the Hyper-V, that's fine too, right? But I like VirtualBox just because it's a more universal type of virtualization, because the VirtualBox, the free of charge version of it, well, that's all there is a free of charge version. It operates on Windows hosts, Linux hosts, and Mac hosts, and it works the same across the board. So it's really cool. For VMware Player, you have free of charge versions for Windows and Linux, but you have to pay for the Mac version for some reason. And of course, Hyper-V, well, it only works on Windows. But anyway, what we're going to do here now is, since I have this virtual machine, you can see over here that there's only one drive attached to it. So I'm going to go ahead and add a couple more drives. Okay, so the only drive I got right now is just the drive that I used to install the operating system when I created the virtual machine. So let's go up here and we'll click on settings, and then we'll click on storage, and on the SATA controller, I'll click on that. Then I'm going to come down here, and on that little thing there, it looks kind of like an old style floppy disk. I'm going to click on that, and I'm going to add a hard disk, and I will create a new disk, and I'll just leave the name there as it is, and I'm going to up that to about 20 gigabytes or so. Not a real large drive, but it's good enough for our purposes. And I'll leave the defaults and everything else. And by the way, this is going to be a dynamically allocated drive. This will not take up 20 gigabytes on your host machine unless you actually fill it up with that much stuff. So click on create, and then I'll go ahead and create another one as well, because I want one to do the MBR demo and one to do the GPT demo. So anyway, let's go ahead here and click on that again, add another hard disk, and create a new disk. And this time I have to change the name because for some reason VirtualBox does not automatically change the name of any additional hard drives that you add past the first one. And I'll go ahead and bump that up as well to about 20 gigabytes. So in real life, you're not going to be working with drives this small, of course, but you know, for our purposes now, it's okay. It works. So click on create, and now we'll click on OK. So now I can boot up the machine. I double click, and it will boot up. And yes, I know it's in scale mode. That's what I want. And it should be fairly quick because there's no desktop interface to wait for. Okay, so we have that. And just to show you that I have updated it, let's do this. See, 7.5. Yay, just what we want, right? So let's go ahead here and let's go ahead and take a look at this with the Fdisk to see what we have. We have sudo fdisk-l. And unfortunately, without a graphical interface here, this is running off the screen. So let's try this again. Let's see how it looks when we pipe it into less. There we go. Okay, so you see up here we have this dev SDA drive at the top. That is the drive on which I install my operating system. And by the way, I forgot to mention that when you normally install a Linux distro, most of the time, most Linux distros, you're not going to have to go through all this manual type of creating your partitions because you have an installer which will do it for you. The installer for most Linux distros is going to decide upon a default partitioning scheme for you. And if you don't want that, you can override it. You can go in and create your own partitioning scheme if you want. For desktop users, you probably are going to be okay going with just the default. For server users, yeah, you might want to partition things in a different way besides just the default. But anyway, back to this. We have the SDA drive, which is our installation drive. That's our operating system drive on which we install the operating system. Okay, how many different ways can I say that? We have the SDA1 partition. It's marked as our boot partition. And you see that it is a Linux partition there, type 83. And I'll get to what all that means in just a moment. And we have the SDA2, which is a type 8E Linux logical volume type of partition, and we'll get to all of that. We'll get to the logical volume stuff in a future video. We're not going to go into it right now, but for right now, that's all we need to see. And also, due to the fact that Fdisk is reading this, it means that this is an MBR type of drive here that we're dealing with. So it is set up with MBR. And then down here we have our SDB drive, and it shows the size of it there, and the sectors, and the size of the sectors, 512 bytes, and all that good stuff. And SDC drive. So this is the way our drive numbering starts out. We start out with the first drive is going to be the SDA, second drive would be SDB, third drive SDC, etc., etc. And it's going to keep going like that until you get to the 26th drive, which will be SDZ. And then if you add a 27th drive, it's going to wrap around and it's going to add another character to the designator. So you would have like drive number 27 would be dev SDAA, drive 28 would be dev SDAB, and so on and so forth. But you're probably not going to be dealing with that many drives on your home computer, maybe in the enterprise, but not on your home computer, surely. And then we can page on down to see the rest of it, and we see the information there about our logical volumes. And again, we're not going to get into logical volumes right now. Right now, all we care about is just normal partitions. So let's hit the Q to get out of that. And what I'm going to do now is create some MBR type partitions on that SDB drive. So let's do sudo fdisk dash, no, not dash, sorry, no dash, sudo fdisk dev SDB, like so. And we have what is a really, really simple interface. Now, Fdisk has been around for a long time. And if any of you are as old as I am and have ever used Fdisk for installing the old DOS operating system, you might be having some bad flashbacks right now, because the Fdisk on the old DOS operating system was really convoluted, really confusing. This, however, is simple. You're going to like it because it's just easy, it's simple, and you've got the help menu here, which is going to guide you through it, so you're not going to have any problem with it. So anyway, we have the command there, M for help. M for help? Well, I like to think of it as M for menu. So let's hit the M key and enter, and we'll see what we have. We have a whole bunch of different commands here. However, in normal usage of Fdisk, you're not going to be using all of these. There are only going to be a few of these that you need to really learn. So for adding a new partition, okay, you see there we have N. N for add a new partition. N for add. Now, N for new partition. Yeah, that's the one thing about this Fdisk. It's a little bit weird, but anyway, that's fine. So N for add a new partition. So let's do that. Let's hit the N key. And by the way, if you know these commands already, you don't have to go to this menu. You can just go ahead and hit the commands straight away. But anyway, let's go ahead here and create a partition type. And the default there is P for a primary partition. So let's go ahead and do that. And we can then do partition number. It's going to be a default of partition number 1. We'll just go with that. And then the first sector is going to be the start of the hard drive. So we'll just go ahead and hit enter to accept that. For the last sector, we can either just hit the enter key to accept the default and use the entire hard drive, or we can enter a size preceded by a plus sign. And you can see over here our size. It can either be kbytes, megabytes, or gigabytes. And nothing about terabytes there, but I'm pretty sure if you were to hit a T, if you had a terabyte size drive, you could probably hit a T in there and it would work. Because the reason I say that is because in the old version of Fdisk that was still in CentOS 5, it did not mention gigabytes, but it just said K and M for kilobytes and megabytes, but it did work with the G. So I'm fairly certain this will probably work with the terabyte size drive too. I haven't tried it, but I'm fairly certain it will. But anyway, let's go ahead here then, and we will we'll go ahead and accept the default there to create the partition of the whole big drive. And now let's go ahead here and look at the P key. We'll hit the P key, and that shows our partition table. And we see there that the entire drive is to be partitioned as a Type 83 Linux system drive. So this is what you're going to use for just normal partitioning with a Linux operating system. But let's say that we don't want that. Let's say that we don't want that. Let's say that we want to delete that. We can go ahead and, well, we can do one of two things. We can either hit the Q key and it'll just dump us out of it, or we can hit the D key to delete the partition. So we can hit the D key like that, and that'll delete it. And the one thing to remember here is that we have written nothing to our disk as yet. The only way that we're going to write something is to hit the W key, and that will write the partitioning scheme to the disk, and it will also dump us out of the program. So until we have done that, we have made no changes at all to the disk. And with Fdisk, there is no prompt for whether you want to do something. If you were to create your partitions and then hit the Q key, it'll just dump you out, and it will not prompt you as to whether or not you want to save. And if you hit the W key, it'll just go ahead and write the partitioning scheme to the disk and dump you out of the program, and will not prompt you as to whether or not you want to do that. So you kind of want to be careful here when you're using this. But anyway, let's go ahead now and hit the N key again. And in this case, we'll go ahead and create a primary partition, partition number 1, first sector, the default. And let's go ahead and make this a 5 gigabyte drive. In real life, you're not going to make a partition quite that small most of the time, but for now it works. And also, we can toggle the type of partition that we want this to be. So again, let's go ahead and hit the M key to bring up our menu, and you will see here we have the T key for changing a partition's system ID. Okay, T for change a partition system's ID. Okay, where's the T come in there? Well, I like to think of it as T for toggling a partition system ID. So let's hit the T key. And we need to enter a hexadecimal code to toggle this to the proper type. I know what the code is for what I want to do, but if you don't know the code, all you got to do is hit the L key. It says uppercase L there, but lowercase l works in this case. This is one of the few cases in Linux where something is not case sensitive. So you see we have all of these different partition types. Most of them you're not going to use. In fact, I'm going to say that probably you only use a very, very few of them. So, for example, you're probably not going to be using a Xenix type. I mean, how long has it been since Xenix has been around? I mean, you're probably not going to use a CPM type. So we can dispense with those automatically, and probably you're going to be dispensing with most of them. So the ones we're going to be most interested in are going to be the 83 type up here, which is our normal Linux partition. 82 is our Linux swap partition, and that's what we are going to do here with this. We can also do a type 8 echo, 8E, which is Linux logical volume partition. We'll get to that in a future video. And we also might do a type FD, which is a Linux software RAID type of partition. But for now, we are interested in type 82 because we are going to turn this into a swap partition. So it's 82 and enter. And now we can hit our P key and we can see that it is indeed type 82 for Linux swap. I don't know what the Solaris means. I don't know whether this was also the type that was used for Solaris operating systems, but for right now, all we need to know is that this is going to be for a Linux swap partition. So now let's go ahead and create another partition, and this time, instead of a primary partition, we will hit E for the extended partition. And this will be partition number 2, and first sector will accept the default. Last sector will accept the default so that we can use up the entire rest of the drive. So now we hit the P key and you see that we have SDB1 is the swap partition and SDB2 is our extended partition. So now what do? Well, understand you cannot use that extended partition directly. The only thing you can do with an extended partition is use it to create logical partitions. And the purpose of using extended and logical partitions is so that you can have more than 4 partitions on a given hard drive. So if I'd wanted to, I could have just made the entire drive one big extended partition and used that space then to create all the logical partitions. But instead, I did like this. So anyway, let's go ahead here and create some new logical partitions. Hit the N key again. And this time you see that our menu has changed. So instead of having a choice of primary or extended partitions, we now can choose between primary and logical, because you can only have one extended partition per drive. But in reality, we can't do another primary partition because we don't have the space for it. So let's go ahead and do L for logical, and we'll accept the default there for our first sector. And for our last sector, let's go ahead and we'll make this a 2 gig partition. And we can do like that. And you can see now that we have jumped from partition number 2 to partition number 5. And that's because the first logical partition on a drive will always be partition number 5. And we can go ahead and create another new one. Logical again. Okay, and we could keep doing this up till we have a total of 16 partitions. Once we get to 16 partitions, that's it. Doesn't matter what size hard drive you have. That's all you can create with your MBR. But anyway, I've done enough there, I think, to give you the gist of this. So let's go ahead here and hit the W key. And so there we have. Oh, you know what? Let's go ahead here while we're at it. Let's go ahead, just use up the rest of the disk. So do N, logical, and we'll use up the rest of the disk for that. Okay? And so there's a P, and there you go. So now we'll do the W. Okay, so that's it for using Fdisk in order to partition a hard drive with the MBR partitioning scheme. So now let's go ahead and look at our statistics again here. Fdisk-L, pipe it into less rather. Okay, so dev SDA is still there, and you see there dev SDB, 23.6 gigabyte drive, and you see our partitioning scheme, and dev SDC is still there, nothing done with it as yet. So hit Q to get out and clear. Okay, so that is creating partitions with the Fdisk with the MBR format. In the next video, we'll look at using Gdisk to create GPT partitions.